Hey guys, it's Andrew here, back with another TouchDesigner tutorial. Today, we're going to be making these, which are basically bouncing trails, bouncing balls, essentially a gravity simulator. And we're going to be doing this using Verlet integration, which is one of my favorite things in terms of creative coding. It's the thing that got me into this entire rabbit hole, and to this day, I still think it's one of the best, most fun things that you can make to really experience how fun creative code is. Um, there's a lot you can do. You can like turn off the gravity, and now you just have these floating trails that bounce around. You can also change it so that when they bounce off the edges, they get faster and faster, which to me is honestly pretty crazy. Um, but yeah, we'll be using the experimental build of the newest TouchDesigner, which includes pops, which makes everything really streamlined in terms of Verlet integration and how to implement it. If you look at this patch, it's only this many nodes long, and I think that you could probably make it even shorter if you wanted to. Um, but yeah, so go on the website and download the experimental one, and we can get started. Make sure to back up your official release though, because who knows what can happen. Okay, before we get started, I want to briefly explain what Verlet integration is, and it's just a way to simulate physics gravity using a point's previous position. And so what that means is that when we're starting the simulation, we're going to need two things. We're going to need a point marked in black, and then we're going to need its previous point. And this can be anywhere. I'm just going to put it like right here. Right? And so what we're going to do is we're going to calculate the vector between this current point and this previous point. And it's going to look something like this. Like this. And this is essentially saying, okay, well, this vector, we can move it onto here, onto this current point, and we're going to be like, okay, push that current point this direction. And so that might look like this, right? But the thing is that, when we have a simulation or like in real life, right, there are things such as gravity and friction. So we also have to consider those things as well. And so friction just means that we're going to slightly make this vector a bit shorter, like so. And then gravity just means that we're going to add another vector onto this to sort of bring it down a bit. And so what ends up happening is that endpoint right here becomes our current position's new position, just based off of some pushing. And we can erase this old position because now that position right here is our old position, like so. And then we just do this over and over and over again. And by doing this loop, we essentially fake a physics simulation. It's a pretty good approximation. And yeah, it looks pretty realistic for just if you want to have some sort of fun artistic exploration. If you want to learn more about Verlet integration, I'll link some videos in the description. But yeah, okay, so to start, I can just delete all of this, and I'm going to get a point pop. And from there, what I'm going to do is I'm going to grab a null and then another null. And so I'm going to call this one initialize, and then this one going to be good. And also I'm going to add a feedback here. And I'm going to separate these two. I'm going to move that back over there. And then this, from this initialize, I'm going to grab a dat pop2. And then I'm also going to grab a transpose, like so. And so now, if you look at this, we have P0, P1, P2. This essentially is telling us where our point is in space. If I were to move this a bit, like so, now we've moved our point up. You notice how that kind of moved upwards. And yeah, this P2 right here, this Z direction is still 0 because we kept it at 0, like so. Anyways, so in our area right here, we're going to initialize all of the parts of our system that we're going to be needing before our simulation starts. And so when I first drew that example, we needed to grab, well, our current point and then our previous point. And so we need to create a previous point. And so we're going to do that by essentially adding a random like so. And I'm going to change value A to be negative 0.01 and value B to be 0.01. And so right now you'll see that it's all offsetting our P0, P1, P2, but we don't want that. We want to make this, and the reason why is because this output attribute scope is replacing our P. But what we want to do is we want to create a new attribute called old P. And so now you'll see that we have a slight deviation, and that's exactly what we want. Now what I'm going to do is I'm going to grab two masks, because what I want to do is I want this to be in 2D. You'll see that this old P right here is affecting my Z direction as well. So what I want to do is I want to basically multiply both of these, and I'm going to add another one like so. Oh, sorry, this should be P2. Yeah, input attribute scope, we're going to set to P2, and then also old P2 as well. And so essentially what that does is it keeps our Z positions at 0. After we have all of those, then we can actually get the simulation attributes. And so what I'm going to do is I'm going to do a attribute here. So, and what we're going to do is right here. So in our create tab, we have the ability to basically create attributes. And so let's think about what we would need. Well, we might need something like friction. And so every single frame, what happens when we throw something? Well, the friction of the air slows it down a bit. And so we might want to multiply our trajectory, our vector, by 0.995. Well, what else is there going to be? There's also going to be gravity. And that might be something like negative 0.01, like so. For now, we can just keep it like this, and we can add more later. But, to double check that we have everything, we can always look into this table. And you'll see all of our attributes, all of our information of this system nicely laid out in our transpose. Okay, so now that we have the first parts of the initialization done, I'm going to move this back here, and we're going to go to the feedback. And in this feedback, I'm going to grab a keyboard like so. And we're going to put that into the start and also the initial. From there, I'm going to add a math mix. So, like so. And I'm also going to copy and paste this. And I'm going to bring this to here to grab our end. Just like that. And you'll notice that nothing is showing up. And that's because we haven't reset our feedback loop yet. And there we go. Okay, great. So now what we want to do is we want to, with this math mix, we're going to get that vector that we were talking about. And remember, our vector that we need is going to be our current position minus our previous position, or P minus old P. And so what we can do is we can grab A minus B here, and all we have to do is we just have to do P minus old P. And this right here, we can call, I don't know, I'm going to call it velocity. Because that's just going to be how I think velocity is a good word. I think that's the right word. Anyways, you can call it whatever, direction, velocity. Just make sure that you keep track of it because we're going to be messing around with this quite a bit. So with this velocity, what is going to happen with it? Well, we can add another math mix. And I'm still new to this, so I'm not entirely sure what the best practice is, but I do like to keep my math mixes in sort of chunks that seem to make sense. So in this one, we're calculating the velocity. In this second one, what we're going to do is we're going to apply the other external forces onto that velocity. And so what we can do is we can now that we have that, I'm also going to add another math mix, and this one is just going to replace our old point with our current point. And so that's just going to be a simple operation of A, where we take in our P and we output our old P, like so. From there, what we can do is we can apply the forces. So one more math mix like so. And the first one I'm going to apply is my vector with my friction. And so what I mean by that is if I were to just do A plus B, that would just be P plus velocity. The thing is that if we're looping that, that's just going to go on forever. We need a bit of friction. So as the ball moves into the air, through the air, it slows down eventually. And so what we want to do instead, right, is for every single frame, we want the velocity to be less and less. And so what we can do is we can do A plus B times C. And so that means that we're going to be multiplying the velocity with friction. And that's going to give us our P. Next we can do is we can do our gravity. And that's just going to be a simple A plus B. And what we're going to do is in here, you can either do this to select your y value, but I personally like P1 like so. And then all we gotta do is we just gotta add gravity like so. And so now that we have that, we can keep an eye on this table right here. I'm also going to basically increase the size of this grid. And then I'm going to zoom in and just find that point that we have. And also I'm going to press Q to turn off adaptive homing so that it stays in place. Yeah, there we go. Okay. And to see this actually run, all we have to do is we have to just grab this end and we're going to drag it onto our feedback like so. Look at that. Balls falling. Now, of course, this is just going to go down and down and down and more down because there is no floor. But before we can we can fix that though. So, but before we do that, I'm going to add a bit more points. And the way that we can do that is one way is you can just kind of press more, but I think that's like way too much work. So instead, what we can do is we can grab a random, and then there's this option called extra points per source point. And so I'm going to drag that to 10. And so then we'll have 11 points. And I'm going to make this value to be 0.20 to negative 2. Like so. And then, like so, well, if we look at here again, we press 1. Look at that. More of them falling. Now, another thing that we can do is we can also increase the values of A and B for our old P. And I think the more that we increase these, the more aggressive our initial velocity will be. And I'm just going to randomize the seed as well. And look at that. Woo! Can zoom out a bit more. But yeah. Now, obviously, we don't want this to basically just, fly off forever. We kind of want to keep this into a constrained area and watch it sort of bounce around and, have it look fun. And so the way that we can do that is Well, we can create our bounds, and then we're just going to need to figure out the math on what happens when one of our particles, one of our balls, hits the edge. If you do end up getting to a point where your end node is like messed up and you can't see everything, don't worry. What we can do is just delete this node, add a new null, rename this one end again, and then just repeat the process, which is just going to be viewer active and then press Q. And then I would say pause your simulation, move the mouse away from that node, reset your simulation, right click, and then press home. Like so. And now, just as long as your number one button is not pressed while you are hovering over this viewer, it should be fine. The moment you do this, things kind of get messed up again. That's something that I discovered. But yeah, start the next part. I'm actually going to select all of these and I'm going to turn off the viewer active because we only ever need to look at this end one, right? All the other ones are just going to be eating GPU and making your patch laggier. So to essentially deal with the stuff that happens, to constrain it into like a box, we're going to need some bounds. And so what I'm going to do is I'm going to add another attribute. And with this attribute, I am going to add a max bounds. So and I'm going to call that 111. And I'm also going to add a min bounds. I'm going to call this one 000. Then I'm going to add a bounce. And think about this somewhat like friction. When a ball or like a point hits a wall, it might slow down a bit. So I'm going to make that 0.998. And then we're also going to need a bounce velocity. I'm just going to keep that at 000, like so. So now that we have all of these down, I'm going to move into my feedback loop. And after my math mix, I'm going to add another math mix that will check for my x bounds. And so the first one that we want to do is we want to check our x position, p of 0, and we want to make sure that it's not going outside of our max bounds, like so. And if it does, well, then we're going to need an indicator, right? So what we can do is we can say x out of max. So now that we have this check going, well, we want to think about, well, what happens if this is true, right? If A is actually bigger than B, what can we do? Well, we have, first of all, this A if C else B. And so that means that if x out max bounds is true, then we could set some A, right? And that is going to be our max bounds. So, because we want to clamp this thing, right? We don't want it to go outside of our screen. And so otherwise, it's just going to be P of 0, like so. And that's going to be outputting P of 0. Now we want to do the exact same thing, but now instead it will be a minimum. So same thing, P of 0. But now we want our minimum bounds. And we want this to be x out min bounds, like so. And then we want another if A then C. Sorry, if A if C else B. And this one is going to be, again, we're going to do min bounds of 0. And then we're going to do P of 0. And then we're going to do x min bounds, like so. And that's gonna just like so. And so if you look now, with all of these set in place, you'll see that they kind of hit the wall. They never actually go past 0 and 1, between 0 and 1, on the x-axis only. The last thing that I'm going to do is I want to create a indicator to just check if basically in either direction it has like exceeded bounds, and that's just going to be a simple max of AB, and it's going to be our max bound and min bound, like so. And we're going to use that later, and this one we can say is x out of bounds, like so. Okay, we have that done. We're going to have to do the exact same thing with our y direction. And so I'm just going to copy and paste this, like so. And before I plug this in, I'm just going to change everything to be in terms of y. So these will all be 1s. These x's will turn into y's. And there we go. And so now we should have something that just keeps our balls inside of our 0 to 1. Now the thing is that that's not very interesting, right? We don't want it to just kind of stop, right? We want it to bounce back. So now we have to actually figure out the math behind what happens when a ball hits a wall. Okay, so we're gonna add one last math mix, like so, and we're going to use this to calculate some interactions that will be used when a point or a ball hits the wall. And the first one is going to be similar to our friction, where we take the P of 0, and we're going to add our velocity of 0, and we're going to make that multiplied by bounce, and we're going to call this bounce velocity 0, like so. Just this one right here. Yeah. Then we're going to do the same logic of the A if C else B, but this time it's going to depend on it's going to depend on x out of bounds. Where is that right there? This one right here. And what we're going to need to do is, well, if our ball is, not out of bounds, then we're just going to have our old P stay the same. But if it is not, if it is out of bounds, we're going to need to set it to our bounce velocity. And if you're curious on why this works out, I would suggest drawing it out and really thinking about what happens what sort of action you want to happen when we're taking previous positions and using that to determine the trajectory. It will help a lot to get a better understanding on why. But yeah, this is basically it. And now we just have to do it for our y-axis. So I'm going to do the same thing. And then one more, like so. And yeah, there you go. But yeah, I mean, what we can do now is we can delete this, we can turn off the viewer, and from there we can add a trail. And then with this trail, I'm gonna turn down the trail length, and then I'm also going to grab this keyboard in and drag it onto the pulse. And there you go. Now it's happily contained, and you can see all the trajectories, which is really fun. And you can render it with a geometry, and then a camera, and then a constant. And then we want just a render. I'm going to make this 1080 by 1080. And with this view in my camera, I'm going to make it orthographic, bottom left, and ortho width 1. And then we can get a null, and we can get a transform, like so. And there you go. Now you get to see all of them. And what else can you do? Well, you can also, you're feeling really fun, you can increase this to more points. You can also go into, so I would suggest probably naming all of these nodes. Um, Again, I'm new to this as much as everyone else is. I didn't really play with the alpha as much as I wanted to. Um, so I'm also trying to figure out the best practices. Right now, what I'm thinking is just sort of having each node do its own little thing. Um, and but the thing is that then you end up having a bunch of nodes that have no information. So maybe, you could write this as like starting points number. Um, this one could be an initial velocity, right? And like this is initial velocity because we can turn this down. Maybe make it like even less. And then this one is just, I don't know, like remove Z. And yeah, I guess both of these are remove Z. And then remove Z again. And then here is like forces or constant forces maybe. I don't know. Really up to you on how to organize it. But you can mess around with this one. You can turn off the gravity completely, and then you get these funny things. You can also increase the bounds. So this should be the bounds, and then yeah. Um, Aside from that, I mean, like that's really what I wanted to show you guys. Play around with it and let me know what you guys make with this because honestly, this is as far as I've explored with pops. This is the first thing I like wanted to make. I don't really know how else to use pops, but I'm going to learn and hopefully you guys can learn alongside with me. Um, but yeah, thank you so much for watching. If you really enjoyed this video, consider subscribing to my Patreon, following me on Instagram, subscribing to my YouTube, the whole shebang. My Patreon members will get every single tutorial file when subscribing, and also a bit of goodies for the higher tiers. And I think for this one, I'm gonna maybe try to figure out collision detection and also make it in 3D. So yeah, Ian, thank you so much. And I'll see you in the next video. Bye!